Once again in my chemistry class. So we discussed the preparation of the phenol. Welcome back once again in my chemistry class. We have discussed the preparation of phenol. So now today we will discuss the acidic character of phenol. That is a very important topic for the examination purpose. So today we will discuss about the acidic character of phenol. So first of all, is it acidic or not? How can we prove it? इसको prove करने के लिए we know that whenever a substance react with base to form salt, it means it is acidic. So if I take 2 or 3 reactions of phenol, one with sodium metal, and when it reacts with sodium metal, then it forms sodium phenoxide with the evolution of hydrogen gas. And here in this reaction it reacts with strong base sodium and it acts as acid. Similarly, phenol also react with NaOH, that is sodium hydroxide, which is also a strong base, and in this reaction also it forms sodium phenoxide along with the formation of water. So here also we get the salt and water as product. Since it is base, it means here this phenol is acting like acid. So these two reactions proves that phenol is acidic in nature. Now how to explain this acidic behavior? अब बात आती है कि हम इसके एसिडिक बिहेवियर को कैसे एक्सप्लेन करें. सो हियर आई एम राइटिंग द रेजोनेटिंग स्ट्रक्चर्स ऑफ फिनॉल एंड फ्रॉम दीज रेजोनेटिंग स्ट्रक्चर वी कैन एक्सप्लेन द एसिडिक कैरेक्टर ऑफ फिनॉल. हियर वी हैव द बेंजीन रिंग which is attached with the OH group, and now here due to plus R or plus M effect, here we can draw the resonating structure, that is O single bond H, and now we have one lone pair of electron here. I am writing it correctly, and if it is shifted here, the negative charge will come to this carbon atom. So this is the first resonating structure, and two more similar structure we can form where the negative charge on benzene and the positive charge on the electronegative oxygen atom is there. And from these resonating structure, यदि मैं इन सभी resonating structures को देखूं, here oxygen acquire positive charge and which weakens the bond between O and H. यहाँ पर ऑक्सीजन पर पॉजिटिव चार्ज आने की वजह से ये OH बॉन्ड वीक हो जाता है, and that's why it becomes acidic. One more thing, if we compare the phenol with the alcohol, if we compare it with alcohol, any of the alcohol, in alcohol generally these are in sp3 hybridized state, while in phenol the carbon containing OH group is in sp2 hybridized state. It means this carbon is more electronegative. More electronegative, it means it will attract the shared pair of electron towards itself more, and that will facilitate the release of H plus ion from the OH group. इसीलिए फिनॉल जो हैं वो अल्कोहल से ज्यादा एसिडिक होंगे. Remember, phenols are always more acidic than alcohol because in phenol the carbon containing OH is in sp2 hybridized state, which is more electronegative, and that's why phenol are more acidic than alcohol. And second, that we discussed already, that the positive charge on this oxygen due to resonance weakens the bond between O and H, which also facilitate the release of H plus ion, and that's why phenol is acidic. So from here we can say that the phenol is a bronzed acid. Now, because it is giving H plus ion, that's why it is bronzed acid. But remember, it cannot act as bronzed base. Why? Because its lone pair gets dispersed and this oxygen acquire positive charge. So now it is not available for donation. और जब ये पॉजिटिव चार्ज की वजह से ये इलेक्ट्रॉन पेयर डोनेट नहीं कर पाएगा, इट मींस इट कैन नॉट एक्ट एज अ लुईस बेस आल्सो, एंड इवन phenol cannot accept H plus ion from the stronger acid also. It means it will not act as bronzed acid. तो phenol ना तो bronzed acid की तरह काम कर सकता है, ना लुईस बेस की तरह काम कर सकता है. It only works like bronzed acid. It can only behave like acid, not as base. Now, if it is bronzed acid, then how it is taking, it react with water. If I take the phenol with water, now phenol is stronger acid than water. It means this proton is given by the phenol to the water, and here we will have the formation of O negative. That O negative is phenoxide ion. This is phenoxide ion, and that phenoxide ion is highly stable. This is highly stable due to resonance. Now, if I draw the resonating structure of phenoxide ion, and if we compare these stability of phenol and phenoxide ion, then we can easily say why phenol is acting like a bronzed acid in water. Suppose if I draw the resonating structure of phenoxide ion. Now, again, shifting of this electron pair between carbon and oxygen, so there will be a double bond, and now we have two lone pair on oxygen, and when it shifts here, the negative charge will be on the carbon atom, and we will have these two bonds. Now, the other structure, little bit I am rubbing this for making the structure clear to you. Again, here we will have two bonds. Now the negative charge on this para position, and similarly the next structure, थोड़ा अच्छा बना देता हूं इसको, क्योंकि बोर्ड पे नीचे की तरफ जब हम आ रहे हैं तो थोड़ा सा ड्रॉ करने में परेशानी आ रही थी. सो नाउ these are the resonating structure of phenoxide ion. Now, what is the difference between the resonance structure of phenol and phenoxide ion? In phenol, in the resonance structure, the positive charge is acquired by the oxygen, which is highly electronegative. It means these resonating structure are less stable, while in this case there is no positive charge on oxygen. That's why these resonating structures are more stable. So if we compare between phenol and phenoxide ion, then phenol is less stable than phenoxide ion. It means the equilibrium will shift more towards the forward direction. ये ज्यादा से ज्यादा वाटर में राइट साइड पर शिफ्ट होगा. इट मींस इन वाटर phenol will donate a proton to form phenoxide ion. It means phenol will act as a good acid, right? So this is the explanation why phenol act as acid. Now what is the effect of substituent? यदि phenol के साथ इस बेंजीन रिंग पर यदि कोई दूसरा ग्रुप हो तब उसके एसिडिक कैरेक्टर पर क्या इफेक्ट होगा, अब हम उसको डिस्कस करते हैं. तो आइए देखते हैं व्हाट इज द इफेक्ट ऑफ सब्स्टिट्यूएंट ऑन द बेंजीन न्यूक्लियस in phenol and how the acidic character varies. So now effect of substituent. So remember there are two very important points. Whenever any electron withdrawing group, electron withdrawing जो अपनी तरफ इलेक्ट्रॉन को खींचते हैं, यदि ऐसा कोई ग्रुप बेंजीन रिंग में ऑर्थो और पैरा पोजीशन पर होता है, that will increase the acidic behavior of phenol, right? Presence of electron withdrawing group increase acidic strength. So remember, if these groups are present on the ortho and para position, means these positions, then only the effect is more and acidic character is increased more. For example, we can say that if we have phenol and it have one NO2 group on para position, nitro group, this NO2 group stabilizes the phenoxide ion more due to its minus I effect or electron withdrawing group. So that's why this paranitrophenol is more acidic than phenol. So remember this point. Only this is important for the examination purpose, that electron withdrawing group increases the acidic strength of phenol, and reverse is true for the electron donating group. यदि हमारे पास कोई इलेक्ट्रॉन डोनेटिंग ग्रुप हो, like alkyl group, means those have plus I effect, then the acidic strength decreases. Means if we have electron donating group, EDG, electron donating group, यदि कोई इलेक्ट्रॉन डोनेट करने वाला ग्रुप होगा, then it will decrease acidic strength. Decrease acidic strength, it means the acidic strength will be less than phenol. इसका मतलब यदि मैं यहां पर कोई मिथाइल ग्रुप या मिथॉक्सी ग्रुप यदि अप्लाई कर दूं, either CS3 or OCS3, it means that will have a plus I effect, and that is electron donating group, so it will decrease the acidic strength than the phenol. So this question is asked many a times in the board examination, that they provide you one electron withdrawing group, one electron donating group, and one normal phenol, and they will ask you to arrange them in the increasing or decreasing order of acidic strength. Only reason is electron withdrawing group increases the stability of phenoxide ion formed by the loss of proton, while electron donating group, obvious सी बात है कि जब यहां पर से फिनॉक्साइड आयन यदि कोई बन रहा है और यहां कोई इलेक्ट्रॉन डोनेटिंग ग्रुप है, that will increase the electron density here, and if it increase the electron density means it will become more reactive, means less stable. So presence of electron donating group destabilize the phenoxide ion, right? This is not a cartoon, this we have explained with the help of lone pair, so it destabilizes presence of electron donating group. अब आप इस पर बेस्ड कई सारे क्वेश्चन करने के लिए तैयार हैं। आपको अलग अलग इलेक्ट्रॉन डोनेटिंग या इलेक्ट्रॉन विड्रॉइंग ग्रुप दिए हुए हो सकते हैं और तब आप उन क्वेश्चंस को सॉल्व कर सकते हैं। थैंक यू।